All right, y'all. So here's part one of building your own track timing system. And it's not building from scratch, it's really assembling it from components that exist. Now, I already done it once. Y'all saw it on my track work track, but I'm doing a new track. And I said I would try to do a step-by-step tutorial. So step one is you're gonna need a car detection system or lap counting hardware, and I'm using the simplest form that I know of. There are several. You can do optical, which be infrared sensor, or you can just do a photo sensor, but that would require like a light tower where you're breaking the light. And I mean, if you want to figure that out, there's plenty of documentation in the race coordinator software. He did a real good job on his PDFs that are contained within the software package that explains the connectivity and what you're going to need. So first, you're going to need to be able to detect the cars and register it to the Arduino board, this is the one I used, and I'll put a link on this video to where I got it on Amazon. I believe I paid $16.50 for this one. And this is physically what it looks like. It comes with a little blue USB cable that's shielded. So I advise to use that. I used a longer one when I was testing, and I did get a communication drop once. So it may require that shielded type USB. It looks like a printer port connection, and there's a power jack here, but you don't need to apply power for it to work. Right, so you load the Arduino with that USB spigot, and then after it's been loaded and you run the software, it detects, and you interface on these headers here, right? And he's got very good documentation on where to connect it. So for my part of this, the first part here, we're using what's called a reed switch. They are super tiny wafers that they're like there's an air gap in there, and then they're encapsulated in glass. I don't know if there's a vacuum in there. Can't really testify to how long they'll last, but these are the ones that I used on my other project, and I did over 100 laps without a single lap drop. It didn't miss any, didn't get any false triggers. But so we're gonna solder some wires, and we're gonna solder a resistor, because on each switch, the race master fellow recommended a 10K resistor. Well, I didn't have any 10Ks handy, so I used a 6.8K, it worked fine. And I work with electronics enough and built radios and things that depending on what the application is, as long as we're not frequency specific, you could go a little higher, a little lower. This is pretty simple circuit. So I used a 6.8, which is blue, gray, red on the bands if you're digging through your box. 10K would be brown, black, orange. And the last band, gold or silver, doesn't really matter. That's just the tolerance that it's allowed to vary. So if you check it with a meter, you would be able to tell whether this thing was degraded or way off or whatever. So we're going to check these with a meter. I'll need a car. Let me grab a car for my tester. And so the way these things work, like I said, is when the car passes across the top of it, the magnetism draws the two plates together, right? And you can see them down in there. You can see the orientation of them, right? So it's on a flat plane this way. So when I glue it in the bottom of the track, I would like the flat plates to be visible to me, not the side of the plates. Although I did get one crooked and it still worked. So they're very sensitive, but we'll try to maintain that orientation. And this is where we're gonna glue them. We're gonna glue it beside a rail, either, you know, next to a metal rail, because that's where the magnets are to keep the track, the car's downforce applied to the track. So right now, but what you definitely want to do, if you don't have a meter, I don't really know, I can't give you a hint on how to check it. But I would say this project you can put together for fairly cheap, but it will take some effort on your part. So if you're not a person that's comfortable with soldering or loading software on a microcomputer board, even though all this stuff is relatively cheap, if you want to be successful and you're not real confident in your own skills, if you're a hobbyist that solders and does things like this all the time, then you should be good to go, right? But I'm not trying to cheat Viasu lap counting software rig out of any money. That's a good setup, that plug and play. I've seen many people use it, and the guy that wrote this software, the race coordinator software, they use a version of that. He's partnered up with them, right? So we're lucky that he hasn't pulled his software down, but he's dedicated to the hobby, and he's donation only, PayPal or whatever, you know. So if y'all decide to use this and you use it and you like the functioning product, do go donate, because it's to a real good cause. I believe his son died from cancer or something like that, and this motivated him to do that in honor of his son, and that's a real honorable thing. So right now I got the leads hooked to this, and it's not beeping, which is a good thing. I got it set on continuity, so when I touch these two leads together, you'll hear it beep, right? So we don't want that reed switch to beep when there's nothing going on. Then we get see that? I ain't even that close to it, and I set it off. That's what we want, so that one's good. Best to test these before you solder to them, before you glue them in, and then after you glue them in also. That one's a go-to. So, and this is a box of them that I bought. I think there were 30 in there. I don't recall the exact price, but I'll post a link to these. I did buy some, I bought a couple different branded ones just in case one wasn't going to work out. Because if you look on a hobby shop page or something, if you buy the Walters brand reed switches, 5 in a pack is 18 bucks. These I think might have been 8 or 9 for 30. They're all made in China. I'm not saying the other ones ain't better quality, but as long as they're glass, because you're going to be using a hot glue gun to put them in there. If they got a metal or a plastic barrel around there, they may get deformed and not function after that. I did have one that failed after I glued it, and I had to pull it out and redo it. So now that we got 2 working reed switches, I got my 2 resistors. First thing I'm gonna do, I'm gonna put solder the reed switches to the resistors. I'm just gonna flip a little bit off the end of one, and it ain't gonna be real fussy or particular about, as long as you don't get too sloppy, you should be fine. And then when we're soldering, you're gonna need a soldering iron, some flux. Definitely want some flux. You want the tip to be clean each time you solder, or you're just gonna make a mess. Oh, I already dropped it. So sometimes when you twist them together, it's not stranded wire, so they don't mesh up real good. So you may have to redo it. Try that again. Man, look at me. Not going good, y'all. I'd like to say that's uncommon, but no, it happens pretty much every time. Once we get it soldered up, we'll be all right. And He sure don't want to stay in there. Like me get them needle nose pliers. Okay. I'm going no direction here. There we go. That's about right. Like I said, dip your tip in the flux every time and get fresh solder on there, and you'll get a good joint. So this is kind of what I want. Want it to be in line right there. So there's the first one soldered together. Do the second one. Turn that off a little bit. Yeah, looks good. There's our second one. So now we got 3 wires we're going to attach. One side of the reed switch is common. That's the other side that I didn't solder the resistor to. So on this resistor side, because that's got to go towards the Arduino, it doesn't matter. It could be in the middle. It really don't care. But just to make it easy for me to glue down all in a row, I'm gonna put it like that. This one. So now we got one lane is red, the other lane is blue for 1 and 2. According to his diagram, the colors don't matter as long as you keep it straight. So I got a piece of wire, 6.8 K ohm resistor, and my reed switch, right? So here's what we're gonna do next. I'm gonna hot glue this down. Now, you've got to be aware on the track, there's some of these areas that have a void where you can get near the track. You don't want any of the metal from the resistor, the wire, or the reed switch touching any of that, right? So you want it to show up in an area, right, where you're not, I don't know how well you can see that, where you're not going to have any metal get near that tap, right? Because you want the reed switch close to the plastic, to that metal rail, because that's where your magnet is, right? And but you do not want to be shorting anything out. So what I'm going to do now, and I see the orientation of my reed switches with the flat plane parallel to the flat surface of the track. So that's good. I'm going to put some hot glue in here to hold that, so I can get it right where I want it. Hopefully this is ready. I'm going to work quick with that hot glue. So you see, put a little blob on the reed switch itself. I didn't cover up any of the metal on the junction between the reed switch and the resistor, because after I get done gluing this in, I'm going to retest it with my meter. And because if you got to pull it out, you fill this bottom of this track with hot glue. Once it's set up, it will be a challenge to get back out. So, but unfortunately, we got to wait a little while for that to set up good enough where I can take my thumb off there, or my left thumb off. And then I'll put another blob down here. Yeah, wasn't ready. So this is going to be the longest part assembling this, plus or minus your soldering skills. But the important thing is that reed switch is up against the track. Your wafers are, you can see that it's flat, parallel to the track is best. And I tell you, I messed one up and it still worked. So, but I'm just saying this is your best bet, keep them parallel because of the way that switch works. So back here, I'm gonna put another glob on that. It's kind of set up a little bit, so I'm gonna put a glob on the resistor. And I'm gonna let it set up. You gotta kind of be patient and take your time because that, like I said, that hot glue's gotta set up. It's got it'll have a bunch of hairs on there. But now I got the resistor being secured down. Next, I'm gonna scoot back and secure down the wire, but I'm leaving the metal end of the junction between the resistor and the reed switch exposed so I get my meter on there to make sure that it's still working with the car on the other side. This end, I'm gonna fold that over and come across, and then I'm gonna do the same thing on the other reed switch down here and join those two junctions together because it's common, and that'll be our black wire. So, but once it's all soldered and secured, it'll be easy to, I say it'll be easy. We'll see about that, right? So, now that's kind of set up good. Want to secure this wire. So here we go. We're going to do and don't get in a hurry with your hot glue. You need to let it set up on its own, because here's a good tip that I learned. If you let that move before that's formed up, or if it's in the middle of forming up, it'll form up with a gap or whatever. Coming back with another blob of hot glue on top of it does not remelt that, right? The hot glue is resistant to its own self when it's hot, but it's very good when it attaches. It loves this track material, I must say. I've used hot glue in other places where it would pop off fairly easy. You got to dig it out with a knife if you mess up. And like I said, it's real good. It's you don't have to worry about it being conductive. It won't mess up electronics. And I didn't mention the wire. I'm using single-stranded wire in this case, and that's fine if you're gonna do it once. Secure your wires down and you never move that wire again. But if you wanna have flexibility, you're gonna connect this thing to a couple different track layouts or whatever, you'll want to use a little heavier gauge. I'm not sure, that's probably 22 gauge, 22, 28 gauge single-stranded wire. But single-stranded wire will break if you keep wiggling it, or it gets crimped and you straighten it out. So in a permanent fixture, it's fine. If you're gonna, like, it's just like Cat 5 cable, they use single-stranded, or not just single wire in plenum, in a rack, but patch cable is always flexible because you're constantly moving it and tossing, so you need that flexibility. But so now we got one with one really long wire here, which I'm gonna roll up right quick because it's gonna be a pain. And in this one, I just made it 6 foot long. I'm using a piece of lifelike track. It doesn't matter what track, but I got a lifelike project coming up. So now I have that one reed switch assembly secured. So it's a good point right now. I need to double check that it is still functioning. And it is. So the heat from the soldering iron and the heat from the hot glue gun hasn't disturbed anything in that mechanical portion, because it is a mechanical switch of the reed switch. So we got one of the lanes done. The next one, so I went to that rail on lane 1 or 2. It doesn't matter what you want to call it. You can turn it either way, whether you want the wires going in or outbound. So the next one will go right here. And you want it about in the same location, because you want the timer each bit. It doesn't matter, because when you go, it can be a little up or down from it. It doesn't give anybody an advantage, because the software knows it doesn't register the first lap until you come around. So if you start back behind it, you go across it, and then the next time you come around, that's lap 1. That's how the software registers it. So if it was a little further up, it doesn't give that one an advantage, because it just don't matter. I mean, it's best that they're semi-close to each other. So again, I'm back on here. I'm gonna solder my blue wire on now. Get rid of some of that resistor. Blue single-stranded, way too long, but that's all right, we'll be okay. All right, got one quick. So here's our next one. Gonna hot glue it now. I'm hot gluing the reed switch first, because I want it to wind up in an approximately good location. I want a little bit. There we go, right there. So that's a good spot. I like to give a little downward bend. Hey, that's right. So I'm near that open gap, but no metal making contact, because the Arduino uses low voltage. So it's basically doing like a digital detection. It uses the chip. You can run it normally high or open collector, or normally low, and then you apply 5 volts and it would register it as a change. In this case, it's we're closing the pin to ground. So in the software, you decide whether it's inverted or not. I'll demonstrate that when we get to the software portion. But like I said, this is probably the longest part, is waiting on the hot glue. But it is an important part, because if I start wiggling this around right now, it won't be where I originally had it, and it'll be further away from the track, and it's hard to fix other than pulling it out and replacing the whole thing. Because like I said, that hot glue, once it starts changing color, you put another blob on there and it'll stick to it, but it doesn't remelt it, which I don't know. I guess that's the nature of the hot glue. I'm not a chemical expert. I'm not really an expert in nothing, but I I have made enough mistakes that I learn a thing or two every once in a while. That's the only way humans learn, through pain. Time to get a new glue stick in there. This is one of my favorite little glue guns right here. It's a mini glue gun. I got it at Walmart. Didn't cost much. But it's just right handy. I think I've used it more in track work and stuff like that than anything else. Homebrew electronics, if I put it, a board or something that I've constructed and I want to put it in something, I'll use hot glue to secure it in there, like I say, because it holds it. Kind of has a little bit of anti-vibration to it. All right, I'm getting closer here. Secure the back end of the wire. All right, we're doggone close now. Woo! Oh man, I'm bumping my meter there or something. All right, so there's blue wire done. So next, so we got the two wires, they're parallel, the layout, the resistors are glued in. I should auto check that one again before I proceed. And it is still working. And what I'm doing, I'm just putting a magnet of the card near it. So now at this point, I'm going to take the other end of the reed switch, bend it over that way. Do the same on this other one. Me shorting stuff out there. All right. So you see I got a little air gap between those two wires. So I'm just going to solder out or strip out a long piece of bare on the black wire, solder it on one side, come across and then tack it down on that one. And we should be good to go. Strip off a good long piece of wire. Just gonna wrap it around there. I'm gonna make the leap across to the other one. Twist them together a little bit. Press down. I'll solder it right quick. So now I'm soldered near the track. You gotta be a little bit careful. Don't want to melt that groove. I'm right near it. You got a little wiggle room though. That's good enough right there. So, now that I soldered you can see what we got going on there. You can see, got the red wire coming in and it goes up to the resistor. Then we hit the reed switch. Then the reed switch the common side goes across. It's soldered to the black wire, then it's soldered to the other reed switch on that side, and the black wire is going to be our common. So all I got to do now is do the hot glue, secure this black wire down, and make sure I don't have any metal near these contact points. And I can drop a glob of hot glue in there to keep from getting any future contact. But right now I'm going to double check the reed switches. So, and my common wire. So plug the common wire up to one side. Oh, do I have a no-go? Oh, my no-go, my meter kicked off. That's what that beeping was. So that one's good, and I'll move it now over to the other side. I'll say I am. There it is. So, it is working. A little less sensitive than the other one. I might have got that orientation just a hair off, but it works on the track side. That's the important thing, right? And it doesn't get set off by the other lane. That's good. So I can't really check it with the meter on the other side of the wires, because on the wires side of these, because we got the resistors that are in there. Now we could have just soldered the wire straight and use the resistors on the Arduino, and it's up to you how you want to do it. I just decided to go ahead and put them in there. So now I'm just gonna cut off my soldering rig. I'm gonna push this wire down in here and secure the rest of this stuff up a little better with my hot glue gun. Pretty good little liberal amount there. When I say liberal amount, I don't mean political liberal. It's not like it's going to be whining at you or something if you put too much on there. So, but here we go. Then we'll turn that wire a little bit. Y'all be careful with that hot glue, because it's sure pretty hot when it gets on your fingers. Set that down. So I done broke my rule and moved it before it had set up. So you're going to end your hot glue mess with down here what we got. Can't really see it because it's the black wire, but I hot glued all along the trail, making sure it wasn't getting near any metal, so the power from the rails ain't going to get near your Arduino. It's going to be isolated. And then my next step would be cut some notches in the side so I can feed the wires through and out, but I won't go into that. You can physically tidy it up however you want. But now I got 6 feet of wire from the lap detector track. Now this is just 2 reed switches. If you want to do another set so you can have pit in, pit out. I haven't messed with that setup. You may need 6 switches to do that setup. I hadn't really got that far into it. I did 6 switches on my other one just because, I mean, once you're at it, you could do another. But like on a 15-inch track, if you did your reed switches at the beginning and then at the end, that's probably a pretty good pit area to be able to stop at for a fuel race or whatever, if you're doing a NASCAR thing or something. But that's about it, y'all. So that's the detection portion. And I'm going to put a link to those reed switches, this Arduino board. I'll look up some 10K resistors and put them in there. They won't be much. But again, if you're not comfortable with doing that, it ain't worth messing with. If you're not confident that you're going to be able to follow these instructions and make it happen. The whole VIASU setup, you get a light tower, the detection thing, the whole kit for like $200 and something for the amount of work that you got to put in there, unless you're a hobbyist like me and you don't care about the time. You know, like I said, by all means, it seems to be a very good product. But if you do something like this, then you can add flexibility, and you got more than one track, you can add more flexibility. You can do this every time, or you can build a little DB9 interface connector so you can move your one Arduino over. But like I said, once you've done one, another 16 bucks, you already got the software, you can reload one. You know, it ain't that hard to incorporate it. So if you got any questions, go ahead, you can post some questions. But like I said, it all depends on your confidence level. If you think this is all foreign talk to you, I'll put it on as layman terms as I can. I ain't no expert in electronics, but I've been doing electronics for well over 40, 50 years. You know, they used to pay me to do it, so I reckon I was a professional. And but there are better folks. So next, I'm going to do the software walkthrough. I found a program where I can do screen recordings. So I'm going to try to have a session where I click each piece of software in the order I did it last time, because to tell you the truth, it was one of the simplest installs I've experienced in a very long time. It went like clockwork, boom, 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 and I was quite shocked at it, to tell you the truth. So if this stuff don't scare you, then that part will be super easy for you. All right, y'all. Till next time.